Bismillahirrahmanirrahim. Assalamu alaikum. I'm Mansoor Ahmad with my YouTube channel Overt Chemistry. I hope that all are going well. You know, dear students, I have started a series of the reactions related to electrophilic aromatic substitution reactions. So today this is my third lecture about electrophilic aromatic substitution reaction of benzene. The today topic is about nitration of the benzene. So let's start our topic. Nitration of the benzene. Since you know that this is electrophilic aromatic reactions, here we specially add an electrophile into the benzene ring. So today we add another electrophile, which is especially a nitro group. So the word nitration here means the addition of nitro group. Nitration means the addition of nitro group. Addition of nitro group. Nitro group means NO2. This is nitro group. Today basically we add this nitro group into the benzene molecule. So according to the procedure of my old lecture, first I will write the definition of these reactions. After that I will write reactions, and in the last I will explain the detailed mechanism of this reaction. So we will start from the very basic, that is the definition of nitrations. So let's write the definition of nitration. What is the definition of nitration? The definition of nitration is very simple. In nitration, we basically replace one of the hydrogen atom of the benzene molecule by the help of nitro group. In such reaction, we use a catalyst which is concentrated sulfuric acid. Along with the catalyst, we also imply the temperature to these reactions. So what does mean by nitration? Suppose this is a benzene molecule. This is a benzene molecule. This is one hydrogen atom of the benzene molecule, and here I will react a compound which contains basically a nitro group. That means a nitrating agent. So what will happen in nitration? In the nitration, this hydrogen atom of the benzene will be replaced by the help of this nitro group. I mean the hydrogen atom of the benzene will replace by the help of this nitro group. So this is called nitration. So I will write the definition of nitration here. The definition of nitration is the replacement of hydrogen atom, the replacement of hydrogen atom of benzene ring by a nitro group. Nitro means NO2. This is nitro group. By a nitro group using a nitrating agent. Using a nitrating agent in the presence of concentrated sulfuric acid, using as a catalyst to form. What will be the final product? The final product is basically a nitrobenzene. To form a nitrobenzene, is known as nitration of benzene. So dear friend, this is the basic definition, the general definition of nitration. What is nitration? Nitration is simply the replacement of the hydrogen atom. Here we will replace one of the hydrogen atom of the benzene ring by a nitro group. This is a nitro group. From what or from which kind of sources we obtain this nitro group? We obtain basically this nitro group from some nitrating agent. Basically we will discuss that what does mean by a nitrating agent. We will discuss it in the general reactions. The reaction is basically carried out in the presence of a catalyst. We use generally the catalyst in this reaction, that is specially concentrated sulfuric acid. So I will tell or I will explain the reason that why we use concentrated sulfuric acid in nitration. I will explain this question in the mechanism. So here nitric acid will be used as a catalyst. What will be formed in the last? Our product which will be formed in the reaction of nitration, that will be nitrobenzenes. So we will also imply the heat. I will write the general equation of the nitration. Through general example, we will understand each and everything related to the nitration. So please note the definition of nitration. Take the screenshot of this definition. Now we will discuss the general reaction of nitration. This is very easy and very this is easy topic. You have not to worry about this topic. So let's start our general reactions. You know, student, suppose this is a benzene molecule. We know that benzene molecule is composed of 6 carbon and 6 hydrogen atom. Here I show one of the hydrogen atom of the benzene ring because I want to do the reaction with this hydrogen atom of the benzene ring. So this is what? This is simple a benzene molecule. With this benzene molecule I will react a compound which contains a nitro group. The compound which contains a nitro group is known as nitrating agent. In the nitration, generally we used a common nitrating agent which is concentrated nitric acid. So concentrated nitric acid is our nitrating agent in case of nitration. So I will write here nitrating agent. Suppose this is our nitrating agent HONO2. This is what different? This is nitric acid, nothing. This is simple nitric acid. So I will write its name. This is a nitric acid. We use a concentrated nitric acid in nitration. So this is basically our nitrating agent. Right? This is our nitrating agent. Okay, what will happen? We generally use a catalyst in this reaction, that is concentrated sulfuric acid, H2SO4, concentrated sulfuric acid. Along with the catalyst we also use temperature. The temperature is from 50 degrees centigrade to 60 degrees centigrade. Why we use this range of temperature in this reaction? I mean that from 50 to 60. In some book it has written from 50 to 70 degrees centigrade. So it doesn't matter. This is the common range which is taken in case of nitration. So I will tell the reason that why we use this range of temperature. If I use a low range of the temperature, suppose 10 degrees centigrade, 20 centigrade, then the reaction will be very slow. We will not get our product, that is nitrobenzenes. So what we use this kind of temperature. Now if we put another question that if I use a high range of temperature, then what will happen? In case of high range of temperature, basically the reaction will be two-post and there will be a product which contains dinitro. So our main product is nitrobenzene, in which only one nitro group is attached with the benzene molecule. In case of a higher temperature, there will be a product which will contain 2 E1 or more than 2 nitro groups. So to obtain only one nitro group with a benzene molecule, that is a simple a nitrobenzene, we use this range of temperature. So what will happen simply, if I use a concentrated nitric acid with a benzene molecule in the presence of concentrated sulfuric acid using as a catalyst with the application of heat temperature, that is from 50 degrees centigrade to 60 degrees centigrade, so there will occur a reaction. The reaction will be like this. The hydrogen part of the benzene molecule will react with the OH part of the nitric acid. So one compound here will be formed, would be a water molecule, because one hydrogen will react with OH negative. This is hydroxyl group. So here one compound will be water molecule, that is H2O. Now this part, the NO2, which is nitro group, which is our electrophile. Now this is the remaining part of nitric acid. This will basically attack on this benzene molecule. I means that this hydrogen atom now leaves from the benzene molecule, and this nitro group will attack on this benzene molecule. So here basically a substitution reaction is done. The substitution reaction means that one or more atom is replaced by the help of another atom or group of atom. So this is the example of substitution reactions. Since this reaction occurs in aromatic compound, therefore the reaction is known as electrophilic aromatic substitution reactions. So what will happen, dear student? Now with this benzene molecule there will be a nitro group. I mean this will be our product. This compound is known as nitro group. This is a nitrobenzene, not nitro group. This will be nitrobenzene, which will be our final product. What does mean by nitrobenzene? Nitrobenzene means that when we add a nitro group with benzene molecule, here you see that one of the nitro group is attached with the benzene molecule, so it becomes a nitrobenzene. So this is the general reaction of the nitration. If I write this reaction in condensed form, then what will happen? I mean we can also write this reaction in condensed form. Suppose I am writing this equation in a condensed form. Suppose this is a benzene molecule, C6H6. This is a benzene molecule. With this benzene molecule, I am using a nitrating agent, that is HNO3 nitric acid, concentrated nitric acid. Again, I am using concentrated sulfuric acid as a catalyst. In the presence of it, the normal range we applied to this reaction is from 50 degrees centigrade to 60 degrees centigrade. What will happen? Two products will formed with this in this reaction. One of the product will be C6H5NO2. Simple. This is nitrobenzene again, and the other will be H2O, water molecule. So this is nothing. This reaction is the condensed form of the above reaction which I have written. This is what? This is the condensed form. So you have to remember in your mind that there are some more nitrating agent which we can use in case of the nitration. Instead of nitric acid, we can also use some of the nitrating agent. For example, this is also a nitrating agent, N2O5. This is what? This is a dinitrogen pentaoxide. This compound is also a nitrating agent because by the help of this compound we can also obtain a nitro group. As I told that any compound, any agent which provide or which give us a nitro group is known as a nitrating agent. So dinitrogen pentaoxide basically also provide us a nitro group. Therefore this is also a nitrating agent. Understand? So we can also use, instead of nitric acid, this compound, that is dinitrogen pentaoxide. Understand, dear student? Some more nitrating agents are with us that we can use in nitration. That's are nitronium salts. What? Nitronium salts. These are also nitrating agents. Nitronium salts, like for example this is N2BF4. This is what? This is a nitronium salt. From this compound we can also obtain a nitro group, that is N2 positive plus BF4 negative. So this compound also provides nitro group. This is also nitrating agent. So instead of nitric acid, again we can use this compound too. One more example, NO2PF6. This is one more example of the nitrating agent. Look at these examples. This also provide us a nitro group, NO2 plus PF6 negative. Understand? This is also a nitrating agent. So we can also use, but as I am telling that in nitration we generally use nitric acid as a nitrating agent, and that is concentrated nitric acid. Understand? Now we will discuss the mechanism of this reaction, how this reaction completes. So let's discuss the mechanism of nitration. Dear student, the mechanism of nitration basically completes in three-step mechanisms. The mechanism of nitration consists of three-step mechanism. This step number one. Let's discuss step number one. The step number one is also known as generation of electrophile. Generation of electrophile. What does mean by generation? The generation means formation, production. So here what we will generate, we will form an electrophiles. So since electrophile is formed in first step, therefore the first step, step one, is known as generation of electrophiles. Why we generate an electrophile in this reaction? Since this is electrophilic reactions, in electrophilic reactions always the initial attack is done by an electrophiles. That is why we generate an electrophile in step one. So you have to remember this in your mind, that this is electrophilic aromatic substitution reaction. Therefore the initial attack is always required by an electrophiles. So that's why this step one is known as generation of electrophiles. How electrophile is formed in first step? Look at these. Suppose I am taking concentrated nitric acid HNO3 with concentrated sulfuric acid. Simply, when I react or treat concentrated nitric acid with concentrated sulfuric acid along with the application of it, then there will be three types of materials will be formed. One of them will be nitro group, NO2 positive, the other will be H2O, and the last one will be HSO4 minus 1. This is hydrogen sulfate. This is what is meant? Hydrogen sulfate या bisulfate ion. Yes. Here basically we take the ratio of concentrated nitric and concentrated sulfuric acid as a 1:1. I mean that 1:1 means that we take the concentrated nitric and concentrated sulfuric acid ratio as 1:1. We take in these reactions. So their concentration is same, the ratio. their ratio will be same in case of the nitrations. So when I react concentrated sulfuric acid with concentrated nitric acid, there will be three types of the materials formed. One of them will be nitro group, which is our electrophile. The other thing will be water molecule, and the last thing will be hydrogen sulfate or bisulfate ion. Now, if I study in detail that how these three materials are formed by these two, so let's discuss. We will discuss now that how these three materials are formed by these two materials. So we will discuss about this step. There is a particular pathway in which these materials are formed. Now we want to discuss that particular pathway in which these materials are formed. Look at this different. Suppose this is a nitric acid. Suppose this is a nitric acid. This is what? This is the structure of nitric acid. Suppose this is what? This is the structure. Here a positive charge comes on the nitrogen atom. Why? You know, generally nitrogen forms three bonds. Whenever nitrogen forms a fourth bond, by the help of its lone pair, there will come always a positive charge on the nitrogen atom. So here is the same case. Here nitrogen has formed its fourth bond by the help of its lone pair. So that's why there is a positive charge. On the other end, on this oxygen atom, there is a negative charge. Why there is a negative charge? Because this oxygen has formed only one bond with the nitrogen atoms. So if I ask a question whether this nitric acid is a neutral molecule or charged molecule, apparently it looks a charged molecule, but in actual the molecule is neutral, because whenever you have same number of opposite charges, then they will always cancel each other. As a result, the molecule becomes neutrals. So absolutely there is the same case, that there is equal number of opposite, that means positive and negative charges. Therefore this negative will cancel this positive. As a result, the nitric acid becomes a neutral molecule. So actually this molecule is a neutral molecule. Now there is two lone pair of electrons on the oxygen atom. This oxygen atom has also two lone pair of electron. Similarly, this oxygen atom also has two lone pair of electron. But I am not showing the lone pair of electron of these two oxygen atom, because my work is with this oxygen atom. So I will focus on this oxygen atom. On the other hand, I will draw concentrated sulfuric acid. Suppose this is the structure of sulfuric acid, OH. Again, there is OH. This is what doesn't. This is, suppose, the structure of sulfuric acid. Now we know what we do. As I told, that why we use acid in these reactions. Now I will tell the reason that why we use acid, that means concentrated sulfuric acid, in such type of the reaction. Now listen the reason. You know, in the nitric acid, this OH part, this is basically a weak leaving group. OH here is a weak leaving group. Our work is with this nitro NO2, with this part of the nitric acid, because this is nitro group or electrophiles. This is what? This is our electrophile. Since this is a stronger bond, this OH cannot easily leave or cleave. This bond is stronger. Therefore, to break this bond, we generally use an acid. What is the job of an acid? The job of an acid is basically to provide a proton. Since this is sulfuric acid, this provides a protons. Now this becomes very easier to cleave this bond. How this become easier? Look at this to this adjacent. As this oxygen atom has a lone pair of electrons, now this oxygen atom will attack on this hydrogen like this. The lone pair of oxygen will attack on this hydrogen atom. Here the hydrogen will give its electron to the oxygen. See, what is the advantage of this step? The advantage of this step is that when this oxygen attacks on this hydrogen atom, this becomes oxygen becomes a positively charged. That means oxonium ion will be formed. When there comes a positive charge on the oxygen atom, now this bond will break easily. When this bond breaks easily, then all electrophile will be generated. As our main as our main function is with a nitro group, which is electrophiles. When we get it, the reaction will be started. So how this is formed? This lone pair will attack on this proton, and this will give its electron to the oxygen. Now this product will be formed. Look at this: nitrogen double bond, oxygen. Here negative charge, nitrogen, positive charge, oxygen, hydrogen, hydrogen. Now there comes a positive charge on this oxygen atom. Why the positive charge come? Because oxygen has formed its third bond by the help of its lone pair. Whenever oxygen forms its third bond by the help of its lone pair, then a positive charge comes on it. So similar as this is the case with the oxygen atom, therefore a positive charge come on this oxygen atom. What will be the other entity formed in this reaction? That will be S double bond O, OH, O negative. I mean that hydrogen sulfate or bisulfate ion will be formed. If I write this in condensed form, this will be formed. Understand? This is hydrogen sulfate or bisulfate. So this is what basically we do here, a protonation. I mean that we protonate nitric acid. So this is basically a protonation. This is what it is not protonation. Now this nitric acid has gotten a proton from the sulfuric acid. Therefore now this nitric acid is known as protonated nitric acid. This is what? This is a protonated nitric acid. Now as oxygen has positive charge, now this is unstable. This is oxonium ion. Oxonium ion is basically unstable in the nature because there is a positive charge on the oxygen atom. Since oxygen atom is an electronegative atom, therefore it cannot tolerate a positive charge on itself. So what it will do? Now this positive charge on the oxygen atom will compel this nitrogen atom to attract this negative charge from this oxygen. Again, when a nitrogen attracts the negative charge, this positive charge of the oxygen will attract again the electrons from the nitrogen atoms. Whenever this positive charge attracts the electron from this nitrogen, from here the NO bond will break. As the NO bond breaks, automatically the electrophile will be formed. So now I will tell, suppose this O negative will give its electron here. I mean this oxygen negative will share its electron with the nitrogen atom. Here will be formed a double bond. As this oxygen give one electron to this nitrogen atom, again as nitrogen atom receives the electrons from the oxygen atom, this oxygen positive will attract the electrons from nitrogen atom. When it attracts an electron from the nitrogen atom, from here the bond will break. So what will formed basically? Look at this. This step will occur. Now look at this. H2O water molecule will released from here, and NO2 positive. Now here comes what? electrophile will form, that is N double bond oxygen, N double bond oxygen, and still positive charge on the nitrogen atom, because still it has formed 4 bond. Understand? So as you know that we generate the electrophiles. This is what? This is electrophile, because this is electron deficient species. Now in second step, the double bond of the benzene will attack on this positive atom, which will be our step number 2. So this is what this one. This is the first step, generation of electrophiles. What? First we will proteination will occur. After that, when this oxygen atom of the nitric acid protonates, here protonated nitric acid will be formed, and hydrogen or bisulfate ion will be formed. So this is a protonation step. In this step, after that, the positive oxygen atom will attract electron from nitrogen atom. The nitrogen basically receive this electron from this O negative. So here H2O molecule will be released. Now what will be used for cleaving this H2O, for the removal of this H2O? The same concentrated sulfuric acid is used for the removal of this H2O. So you have to remember, here we use again what? Concentrated sulfuric acid as a dehydrating agent. Keep this point in your mind, that again we use here concentrated sulfuric acid, which will work as a dehydrating agent. What does mean by dehydrating agent? Any agent which captures or which tries to capture water molecules. So as this concentrated sulfuric acid helps the nitro group, how it helps? This basically here in this case, the concentrated nitric sulfuric acid compels the water molecule to apart or to leave this nitric acid. So here we use as a dehydrating agent, that is concentrated sulfuric acid. So this is step number 1, which is what? Generation of electrophile, which is basically, this is our electrophile. Now we will discuss second step. Now we will discuss step number 2. Note the step number 2. There is a particular names to step number 2. The first name is formation of benzenium ion. Formation of benzenium ion. Step number 2 is known as formation of benzenium ion, or sometimes we also called it as formation of the sigma complex. Step 2 is also known as formation of the sigma complex. I will tell the reason that what does mean by sigma complex, or what does mean by the benzenium ion. Yeah, we also called this step as formation of the rhenium ion. Again, I will explain this in step, that why it is called formation of rhenium ion. Yeah, formation of the carbocations. These are the different names given to step number 2. I will explain the reason of all these steps, of all these names. So after that, which name do you like most? You have to write this in comment box. In this 4th name, I will explain the reason. After that, which name do you like the most? You have to write this in a comment box. So please write in comment which name will you like the most. I will tell the reason of all these names. You know, in step number 2, this is a benzene molecule. This is what? This is a benzene molecule. This is one of the hydrogen atom of the benzene molecule. Now what happens is, this is what a nitro group, and this is what, this is a nitro group, which is our electrophile. Now since nitrogen contains positive charge, it means that it is electron deficient. The double bond of the benzene will attack on this nitrogen atom. I mean, here will a bond will be formed between one of the carbon atom of the benzene with this nitrogen atom. This is impossible that a nitrogen atom form 5 bonds. This is highly unstable and highly wrong case with nitrogen atom. Generally, as I told, nitrogen form 3 bonds. Sometimes nitrogen forms 4th bond by its lone pair. When it forms 4th bond, there will be a positive charge. Now instead of positive charge, it is impossible how to form nitrogen 5th bond with the carbon atom of the benzene molecule. This bond formation is only possible when here one of the oxygen atom breaks a bond with nitrogen atom. Suppose this double bond breaks, or you can also break this double bond, because the bond energy of both this NO N double bond O and this N double bond O are same. So how it will form? I will suppose form this double bond. So when this attack on this, there will be a sigma complex. What will form? There isn't a sigma complex. Look at this. Sorry, the double bond will. Now this complex will form. Here hydrogen atom, here NO2. Understand? Here positive charge comes. Now this will formed. Understand? This will formed. If I show that what happens to this bond, you can also write like this. For your concept, I am writing here nitrogen. Understand? Here what? Again, this is mixing with hydrogen atom. I do not want to mix. This is hydrogen. Now this is nitrogen. Here what? O negatives. This is double bond and positive charge. Understand? Basically, look at to this sigma complex. This lies in this state. Here what? Here N oxygen double bond. The double bond will break. Why the double bond break? Because this nitrogen atom will form a bond with this carbon atom. Now I want to explain this compound. What is this compound? This is known as benzenium iron. As I have also written that this is a benzenium iron. Now I want to explain the reason that why this structure is known as benzenium iron. As you know, this compound, this structure basically contains a benzene ring. This is what? This is a benzene-like structure. Now this is not a benzene. As here a double bond is formed. Understand, student? This is what I mean benzene. Here a positive charge is present. So this is known as benzenium iron. In the last here neum is used. Neum always represent a positive charge. Understand? Like when a positive charge comes on carbonium, then it is known as on carbon, then it is known as carbonium. When a positive charge comes on the oxygen, then it is known as oxonium. Understand? So when a positive charge comes on water, that is, then it is known as hydronium. So similar is the case. As here a positive charge comes on the benzene, that's why it is known as benzenium iron. Why this is also called a sigma complex. Now listen the reason why this is also known as a sigma complex. I am telling the reason. Look at this compound. As in this molecule, this is a simple benzene molecule, here a double bond is present. Here is a pi bond. After what? When the double bond of the benzene attacks on nitro group, now the double bond finishes. The double bond is vanished. Basically, the double bond of the benzene is converted into a single bond. We know that single bond is known as a sigma bond. As double bond is converted into sigma bond, that is why it is known as sigma, and the structure is complex because there is a positive charge. That's why it is known as a sigma complex. It means that there is a single bond, it means there is a sigma bond. Along with sigma bond there is a complex. That's why this is known as sigma complex. This is the reason why it is also known as uranium iron. This structure is also known as uranium iron because again here is a positive charge. You know that the word uranium is an alternate name of benzene. Uranium is the name of benzene. Since again there is a positive charge on the benzenes, that's why it is known as uranium. Uranium means arene is the second name of the benzene. Since there is a positive charge on the arene, that's why it is known as uranium iron. The last is very easy, that is carbocations. This is also known as a carbocation. Why it is also known as carbocations? Carbocation is very simple. Whenever there is a positive charge on carbon atom, it is known as a carbocations. Or carbocation is also known as carbonium ion, as I told. So similar is the case. Here is a positive charge on this carbon atom, that's why it is known as a carbocations. Now it depends upon you, which name do you like most and why you like it most. Please mention it in comment box. Understand? Now what? This is basically a resonance, a stabilized structure. It basically converts to this one. Now a question rises that why a stable compound is converted into unstable compound. This is stable compound because in the benzene a process of resonance is taking place. But in this kind of compound, there we destabilize the stability of benzene molecule because we disturb here the conjugation present inside the benzene molecule. So why we do these steps? Listen the reason of this question. This is a carbocations. If this compound was not conjugated, if there was no conjugation in this compound, in this benzene molecule, so after forming this positive charge, here a nucleophile will directly attack on this positive charge. What would ever happen when the nucleophile attacked on this position? There will be addition product. Addition product will be formed. But as we know, this is a resonance stabilized structure. There is a conjugation. The compounds, especially this part, this sigma complex, do specially alternates or change its position. What it will do? It will do a substitution reaction rather than the addition reactions. What is the reason? The reason is that if it goes under through addition reactions, the stability of this compound will be lost because the resonance will be stopped. If it undergoes substitution reactions, that is, the hydrogen atom will be replaced and nitro group will attach. So there will be what different? There will be the same conjugation, the same resonance will be sustained, will be continued. So that's why it will do what? Basically, this is also a resonance stabilized structures. So what it will do? Note this. that this is also a resonance stabilized structure. How it is resonance stabilized structures? There are 7 to 8 conditions for conjugations. In this 7-8 condition, there is a condition which is basically like this. When there is double bond and a single with double bond, suppose if this like this situation present in a compound, then what happens? This is what there are basically 2 double bonds which are present at alternate position. If there comes a positive or double bond, then to this double bond directly will attach a single, and to this single there will be direct a double bond. If this situation comes in a compound, then this will be conjugated and the resonance will take place. Understand? Like this example is present in this molecule. This is one condition of the resonance. There is one more condition. If there is double bond, then single bond, then positive charge. Like this one, double bond, single, positive charge. In this type of situation, there is also a conjugation. The compound will go through a resonance. So this is also a resonance stabilized structure. So here will again a resonance will take place. This pi bond will shift here. So one compound will be like this hydrogen NO2. Now there will be double bond here, positive charge will shift. Understand? Now this double bond will shift here. Still the resonance is present. Now what will happen? Again a resonating structure will form NO2. Now there is double bond, positive charge will come here. Now to next this carbon, is there any conjugation? No, because this is what? This is positive charge, single bond, but there is no double bond attached. Here is also single bond, there is also single bond, and this is also a single bond. So there is no further more resonating structure will formed because the conjugated system is no more present in this side. So these two will form basically the resonating structure of sigma complex or benzenium ion or uranium ion. This is a step number 2. Now what happens in the last step? Now this is a last step. This step number 3, which means elimination. Elimination means removal of proton. In step number 3, proton will eliminate. How the proton will eliminate? Look at this sigma complex. Look at this sigma complex. This is hydrogen, this is NO2. Here is a positive charge, here is double bond, and there is also a double bond. Now as hydrogen sulfate was formed in first step, now the same hydrogen sulfate, that is S double bond OH O negative. Now this O negative will abstract the proton from this hydrogen because the benzene wants to stabilize itself. How it will stabilize itself? It is only possible when this carbon atom of the benzene leave this proton. So how who will be responsible for capturing this proton? This is the duty basically of this conjugate base, that is hydrogen sulfate or bisulfate ion. So this will attack on this hydrogen atom, and these electrons or proton will shift its electron to this carbon, and this carbon will in turn shift towards this positively charged carbons. So what will happen? Our final product will form, which is nitrobenzene. How it will form? Again there will be double bond, here will be NO2 and H2SO4. Sulfuric acid will be formed as it was in the initial, because this is the duty of a catalyst. Catalyst always initiate or take place in the initial of the reactions, and in the end it comes in its original state. Since we used concentrated sulfuric acid in the form of H2SO4, at the end it forms in the same, that is in its original state. So this is all about the mechanism of the nitration, which is very simple. Now I want to review the whole class. What we read in today's lectures, we read about the simple nitrations. Simple nitration means we replace one of the hydrogen atom of the benzene by the help of nitro group. We use a catalyst, that is concentrated sulfuric acid. We taught the reason that why we used concentrated sulfuric acid in this reaction. We read, understand, after that we studied the detailed mechanism of the reaction that was consist of 3 steps. The first step was the generation of electrophiles, the second was formation of the carbocations, and the third was elimination of the protons. Since in the last step proton was eliminated, therefore this step is known as elimination of the protons. So this was all about the nitration of the reactions. We will inshallah meet in next class. If you have liked my lecture, please subscribe to my channel and press the bell icon for the more lectures. See the next time we will meet inshallah. Allah.